Okay, welcome back. We're going to continue on piecewise function. But unfortunately, before those files were gone, excuse me, piecewise functions. And it looks like we cannot do that example. I tried multiple times to graph this function, which is in your homework, but I trust that you guys can do it. Okay. So I'm just going to put up the question here and you graph it yourself. Okay, so every time I started that software is not working. It just run. So I can see that there's a limitation on this software. It doesn't run these pictures very well every time. Okay, and I don't know of any other software. So for these kind of questions, you really cannot rely on your device. A lot of the devices do not have the capacity to do it. Okay, so you have to rely on the method we learned in class and do it yourself. Okay, so we'll give up on that example number 6. So let's do another one. Okay. I'm taking some risk for this one because this one has sine, cosine, and stuff, but I just give it a try. If it doesn't work, and it just have to try it before we know if it works, right? So this function has 3 pieces, so I'm going to use some simple functions in this case. Okay, and this one has 3 pieces. Okay, so 1 plus x is 1 piece. X squared is another piece. I hope they would do this one. 2 minus x. I think you got the idea. It just, you have to practice it, sketching it. And you know that we cannot rely on the devices. Okay. And I don't know any other device, okay, that would do the work every time for you. So we really need to be relying on ourselves. And this function is very interesting because it's not defined on the entire number line. Okay, it's not defined on the entire number line. You can see it's not defined at -1, it's not defined at +1. So let's see if it will graph the picture for us. It does, yay, wonderful, okay? And it looks right, okay? So we just have to put the dots and circles in place. So we just have to put the dots and circles in place, yes. Okay, so let me adjust the view a little bit. Okay. -5, +5, and this is going to be -5, +3. I think that should be sufficient. Okay. So what you can see that from less than -1 is a straight line. Between -1 and +1, that's parabola. From larger than 1 is a straight line. Okay, so we get a straight line. So now we need to put the dots and circles in place. Okay, the dots and circles in place. The place you're looking for is at the end of each interval. So -1 is a problem point. And obviously at a -1, the function is not defined. So we need to put a circle on both places. Okay, we need to put a circle on both places. Okay, so the first place is going to be -1, 1. And that's going to be a circle. And the second one is -1, 0. So -1, 0 is going to be a circle. So we have 2 circles. Okay, 2 circles, because the -1 is not defined by the function at all. And this spot is not defined at +1. So we need to put a circle right here. Okay, so we need to put a circle right at the point, at the pointy place. Okay, so 1, 1. So you have to identify that point, and that point is undefined. Okay, so when you plot points, you can plot point, but we're pretty familiar with these functions, right? Straight line, parabola. So that will be the complete picture. So if you do something like this, when you're given a function like that in your calculus class, you will be good and you'll be ready to proceed with other questions that related to calculus subject matters. Okay. So let's do a couple more. Let's do a couple more. Example number 8. Okay, I couldn't figure out why that software doesn't do the sine cosine function like that. Okay, maybe at the end of the class, we give it one more try, right? If it doesn't work, I just close it. I just close the lecture. And this one involves 2 pieces. Like you're going to see exponential functions. Okay, you're going to see exponential functions. So this function is going like this. 2 pieces. These 2 pieces are, okay, e to the power x and x squared. Okay, we have 2 pieces here. So if x is less than 0, x is less than 0, if x is greater than or equal to 0. Okay, so this, in this case, it's defined on the entire number line. And the graph, that's the graph. Okay, so I'm going to make some adjustments so you can see better. So, and over here, make it 3, -1, so make this 8. Okay, so that's the picture. That's the picture. Okay, it's a right picture. It's a right picture. But we have to put the dots and circles in place. You can see this piece, the second piece is a parabola, includes a 0. So at 0, 0, we should have a dot. Okay, so at 0, 0, we should have a dot. So 0, 0 should have a dot. Okay, but at this point, it should be a circle because the first rule only apply to very close to 0, but never is 0, right? So, and that point is 0, 1. So that point should have a circle in place. Okay, so 0, 1, which is going to be a circle. And there you go. Right, see this piece is e to the power x, just the negative side for x less than 0. On the other piece is a parabola. Okay, domain, what's a domain? Domain is all real numbers, and the range is greater than or equal to 0. So e to the power x range does not include 0, but x squared, the range is including 0. So if you talk about domain and range, in this case, right, the domain is all real numbers. So you need to be careful when you decide domain and range. You really have to see the intervals in the statement of the function when we have pieces. Okay, and so this range is going to be between 0 to infinity, including 0. Okay, so let's look at another one with natural log x. Okay, with ln x. Okay, so I want to include a variety of functions in these pieces, and this one we have 2 pieces. So I'm kind of splitting this piece. right? The rule has changed, not the same function. One is negative x, but this is less than or equal to 0. And over here is ln x. For x is larger than 0. So it makes sure that both are, ln x is well defined. Right, domain is ln x. So now we're going to graph this function. It does it for us. Very good. It's a good job. Okay, the software, thank you. So this is the software, right? And we're going to choose a proper view. There you go. That's the picture, right? You can see the natural log x is getting as close as possible to 0, but never touch the y-axis. And this is the line. So we're going to put the circle and dots together. So, and this is the line. Does it include 0? Yes, we have a dot. We have a dot. So 0, 0 should be a dot right there. Do we need to put any circle there? The answer is no. We don't need any circle. We don't need any circle. So that's the picture. If I want to make the picture just look a little bit better, right? So you can see more of it, okay? Because this piece will never touch the y-axis. Domain, what is a domain? All real numbers. The domain is all real numbers. And what is the range? What is the range, do you think? I think the range is from negative infinity to positive infinity. Okay, so domain, all real numbers. Okay, and the range, you can see domain from here, right? Less than equal to 0, greater than 0. All numbers are included, right? So range is all real numbers from negative infinity to positive infinity. That's it. Okay. So we have done all these variety of functions. So let's look at this other one. Okay, this one, example number 10. Example number 10. 3 pieces. Okay, so this function has 3 pieces. Okay, one more row. And of course, we'll give it a name to the function, popular name, the most popular name, right? And this function has 3 pieces, x plus 2, which is a line, and 1 over x. Okay, that was one of the basic functions, and the root of x minus 3 functions. And we got some intervals. Okay, we got some intervals, of course. If x is less than or equals to 1, x is less than or equals to 1. And the second interval is 1, 2, 3. 1 less than x, x is less than 3. Okay, the third interval is x is greater than or equals to 3. It looks like all real numbers are covered. All real numbers are covered, right? Domain is all real numbers. So we got this interesting functions, isn't that? Well, of course, we're going to check if it's true, of course, because I start to grow a little suspicious sometimes, right? If it doesn't feel right. So you must check if you have a device, do not believe in it blindly. Okay, do not believe it. Less than negative equal to 1. So this is a straight line. That looks right. So you can plot a couple points in this interval to get that line. And then you have a piece here from 1 to 3. So 1 over x is just a piece of it. And then x is greater than equal to 3 right there. Okay, so these 3 pieces looks right to me. Okay, but always verify. Be sure you verify when you have doubt. Okay, verify by plotting points. Okay, promise me do that. Promise me to do that. Okay, so now I have verified that and kind of, you know, and if you find there's anything suspicious about this question, please feel free to let me know. Okay. So -4, and it's going to be 7, -3. Okay, I'm just pick some numbers. Let me just pick some numbers. So we got a couple pieces, right? There's a piece here, right? So there should be a circle dot. Somehow we have to decide that. Well, less than or equal to 1. So the first place is that equals to 1 is going to follow this rule. So that's the line. So this point, when x equals to 1, the output is 3. So that should be a dot. So 1, 3 should be a dot. There. That's a dot. If this is the dot, and this piece should be a circle. But this piece is on 1 over x, right? So that should be a circle. When x equals to 1, 1 over x should be a circle. Wait, let me cancel that. Okay. So we're going to add, okay, 1, 1, and that should be a circle. That should be a circle because this point, this piece is 1 over x. When x equals to 1, 1 over x equals to 1. But this point, this rule is not the rule of the function when x equals to 1. So we have put a circle here. So dot circle. Okay. So next, for x equals to 3, for x equals to 3, we cannot use this rule. So that rule, which at the end of here is going to be a circle. It's going to be a circle. Okay. So when x equals to 3, it's 1/3. So 3 1/3 is going to be a circle. 3 1/3. That's going to be a circle. There, 1 circle. Okay. Now, at 3, we're going to use this rule. So when x equals 3, root 3 minus 3, that's going to be 0. So 3, 0, right? 3, 0, oops. 3, 0. Let me start over. Okay, so 3, 0 is going to be a dot. And you must verify everything. You must verify everything. So this is how this picture looks like. 3 pieces. You have to have the circle, right? You see the piece in the middle. It doesn't include 1, doesn't include 3. So you have to identify these points and put dots, put circles as needed. And these other 2 rules, they include the endpoints 3 and endpoint 1. So you have to put these in places correctly. Okay, so you must be able to do this. Otherwise, you're going to lose some points. You're going to lose actually quite a lot of points in calculus class. Okay, so let me make just a little more adjustment. So the picture can be better. Okay, so verify your plotted points piece by piece, piece by piece. I think we have covered a lot of these functions. Maybe we do a couple more. Okay, so which number have we done? 11. Okay, since most of these, I mean, 99% of these are from your calculus textbook. And I also hope you to study these carefully before you sign up, before you start your calculus class. So I will do just a couple more for you. Okay. Ah, this one is interesting. This one is interesting. You're gonna like it. You're gonna like it. Okay. I still remember this function when I was teaching calculus class right here. 3 pieces, 3 pieces. Okay. So I basically try to give you a variety of cases that you might encounter. So 3 pieces, you have a cosine x, you have a 0, and you have a 1 minus x squared. These functions, they're all pretty, basic, but it comes in 3 pieces. So if x is less than 0, we know cosine function, right? If x equal to 0, and the next one is if x is larger than 0. Okay, you may notice that in this case, there's one input for 0. The rest of it either larger than 0 or equal to 0. It's the function obviously defined on the entire number line. Let's see if we do the graph for us. Ah, interesting, huh? So we got something like that. Let me make some adjustment. Okay. So that's going to be -5. We'll make more adjustment as needed. Okay. There. They're all connected. What's going on, right? So less than 0, right? This is less than 0. That's a cosine curve. That's all right. And larger than 0, that's parabola. That looks right. But at 0, they connected. But here we're told when x equals 0, the function is going to be 0. So that's not meant to be. So what we need to do is that we're going to have a dot at 0, 0, because when input is 0, output is 0 right here, right? So we're going to have a 0, 0 as a dot. So that, but if this is here, then it cannot be here. This place has to be a circle because of vertical line test, right? If it's a function, for each input, there's exactly one output. So for input is 0, the output is 0 as specified by the function. So this place right here at the connection, it has to be a circle. So that point is 0, 1. Okay, so adding a circle, 0, 1, red circle. There. So when we draw that vertical line, it has only one point contacting the curve. Okay, so let me just make the picture a little bit more friendly and looking a little bit better, just like that. So this is the curve for that function. Domain, range. What is domain with the range? With the domain with the range, right? You can see cosine is going on forever on the other side. Okay, so if you want to see cosine curve, because you want to see more of a cosine curve, so let me give it -10, right? So even though the highest point here is not 1, but the highest point here can be 1. So the range, right? Domain is all real numbers, and the range, so from -infinity to +infinity, that's a domain. And the range is from -infinity to +1. Okay, -infinity to +1. -infinity to +1. Okay, because you have to look at the vertical, span. The vertical span, you can see the highest is 1, even though it doesn't reach 1 here, it reaches 1 here and in the other direction. And negative infinity, which is can be as low as possible because this parabola. Okay, so that's how we get the domain and range. Okay, now let's do 12. Okay, so let's do, okay, I'm gonna try number 12. Example number 12, okay, that's not necessarily the homework question on number 12. And this one has exponential function in place. And then we're gonna do a trig function. If it doesn't work, if the software doesn't run for us, and then that will be the end of it, okay? And if you have any questions, please reach out to me. Okay, I can help you in the office hours, okay? Or worst come to worst, we just graph it by hand, right? So this one has 3 pieces. Oops, e to the power x and 2 minus x. Okay, so if x is less than 0, if 0 less than equals to x less than equals to 1, and of course, if x is larger than 1. There we go. So define on the entire number line. Draw a picture and look at that. Okay, so first we need to check if this is right. Okay, if this is right. So we have to use our knowledge about these functions. We have to use our knowledge about this function. The middle one between 0 to 1, that's e to the power x. That looks like it, right? 2 minus x is a line decreasing, x plus 2 is a line increasing. So we just have to put the proper circle dots in place. Okay, so I'm going to set the view. There. Okay, just made some adjustment. So put this function over here next to it. So this way we can see everything. Less than 0, right? Less than 0. So this rule only applies to less than 0, not including 0. So when this rule is considered, right? When x equal to 0, y equal to output is 2. So this place must be a circle. Okay, so 0, 2 is a circle. You guys got the hang of it, all right? 0, 2 is a circle. There, so that's a circle. Between 0 to 1, that's e to the power x. So both ends are included. 0 is included, 1 is included. So here we should have a dot. 0, 1 is a dot. Okay, so 0, 1 should be a dot. And there's another dot. When x equals to 1, when x equals to 1, e to the power x is e, right? So 1 comma e should be a dot. So right there. Okay, so 0, 1 here, 1 comma e right here, right? And there's the last one. This is going to be a circle. Excuse me, this is going to be a circle. So when x is equals to 1, we cannot use this rule. But when x equals to 1 is 2 minus 1 is 1. So that is not going to, this rule is not going to apply to 1. So we have to put a circle right there. Okay, so 1, 1 is the rule. 1, 1 is a point, right? And that point, we have to put a circle there. There. So this will be the complete picture of this function. Okay, this will be the complete picture of the function. All right. And so as I promised, we're going to see whether our function will perform the trigonometry for us one more time. Okay, and so this rule, I'm going to example number 12. Okay, and of course the functions are going to be different. So it's 1 plus sine x. Okay, for x, if x is less than 0. And here is a cosine x if x is between 0 to pi. The last one is sine x when x is larger than pi. Okay. All right. So this is here's the deal. I'm going to save the file so I don't lose things. Again, I'm going to evoke the software, but I believe you guys can graph this. I believe you guys can graph this. Okay. So if the software doesn't work, we just stop and I just leave it for you or for your future calculus class. Okay. If it does work, and then we will have a picture. Cannot plot this expression. That's interesting. But I don't want you guys go empty-handed. You can see the limitation of this software, right? Doesn't do it. But at least it doesn't, it doesn't just do nothing, right? So what I would do for you is that I'm going to do 3 pieces and put them together. Okay, we're going to do 3 pieces. If the software doesn't do it for us, so I'm going to do this piece. I'm going to do 3 pictures. I'm going to do 3 pictures. Okay, I'm going to do 3 pictures and you piece it together and we can try to piece it together another way. Okay. It's hard to find a software to do a perfect job for us or do everything. This software does have limitation. Okay, so the first picture, I'm going to tell you how I make it. So maybe I can try this. Okay, I think I can try this. So I'm going to graph 1 over sine x. Okay, so 1 over sine x. 1 plus sine x. Okay, that's a black. Okay, the second piece is a cosine x between 0 to pi. Okay, cosine x. Okay, and cosine x, let's use a different color. I'm going to use green. Okay, the last one is sine x. We know this is, if we put together like this, that's a terrible mistake, right? So we have to clean up. And the red, 3 colors. All right, so what are we going to do? With the help of Zoom software, I think we can do something about it. Okay, first of all, that you can see 1 plus sine x, which is the black one, less than 0, right? So what we can do is that I'm going to take the white and I'm going to white it out. I'm going to white it out. Oops, it's not eraser. I'm going to draw, I'm going to white this out. Does it do it? Does it do it? Yes, it does. Thank God. Okay, white out. I'm going to white it out. Okay. There we go. All right. There we go. Oops. Gone. This might simulate some of the work you might have to do on your, if you do it on paper. Okay. And we need a little circle at 0. So for the 1 plus sine x, right? There's a black one is 1 plus sine x. So I'm going to put a little circle here. Oh, that circle cannot be white, so I have to change the color. Okay, so there's a circle here on the black curve. For the green, right? The green is a cosine. The cosine only between 0 to pi. Okay, green is between 0 to pi. So what are we going to do? The green is going to be gone on this other side. Okay, so I'm going to white it out. Oh, see, Zoom is really helpful. Okay, so allow me to just clean it up. And then for you, when you do this, you make sure you use paper, pencil, eraser. So that way you can clean it up. So the green only show up between 0 to pi, right? So now, so the green has to show up. Okay, remember at the end, our final product has to be a function. In other words, it has to pass a vertical line test. Okay. So here, I'm white it out. Wow. I should also white out the red, right? Oh, yes, why not? So I'm going to white out the green and all of these together. So this will be so much easier, isn't it? White it out, white it out. Yay. Then we lose that line. We lose that line. Okay, never mind. So we got the line. Okay, we can put the line back in. Right, we can put the line back in. Yes, we can do it. Oh, I need to be black, sorry. So it need to be black. Prepared. So that's the piece for 1 plus sine x less than 0. But the green, which is a cosine from 0 to pi, this is 0. So we should have a dot there, okay? And that dot happened to be coinciding with it, with the green, right? So we're gonna put the dot, we're gonna put a green dot. Okay, so I'm gonna erase this red circle. I'm gonna put a green dot. Actually, it doesn't matter what color the dot, it's just a dot. Okay, it's a dot. So that's going to be the dot. It just happened that these, it's a dot. And we need to remove the red because red only show up after pi, right? So this is 0 and this is a pi, right? Pi is here. And before that, all the red are going to need to be gone, right? All the red need to be gone. So I need to remove the red. Okay, could you please disappear? Yes, the red show disappeared. Ha. Just disappear, please. Let me do this. Right? The red will disappear. Disappear, please. Doesn't that look better? All right, we have more red to erase. Okay, but we need to know where to end, right? From 0 to pi, that's where green gets to. So we need to have a dot for the pi. Okay, so we need to have another dot for the pi. So it's right here, the lowest point of cosine. So there's a dot over here. Okay, that's the dot for 0, for pi -1. Okay, pi -1. Okay, and we continue to remove the red. Continue to remove the red. There we go. So what that do? It does. Huh. Gone. Wait. No. Too much. I erased too much. Right? I erased too much. We need the red. There. Okay, so we need a red. So the sine x at pi is 0. So now as we erase it, only up here. Oops. No. We need to erase them. Okay, a sine, which is a red, sine is a red. So we need to have a dot here. We need to have a dot here. Okay, because sine pi is 0. Right? Sine pi is 0. Okay, I'll give you a complete picture very soon. Okay, so now we're gonna have a red dot. No, I'm sorry, red circle for sine pi. So here we need to have a circle. No, this is a dot. That's not right. We need to have a circle. Yes, circle right here. So this red, there's a circle. Geez. Be patient with me. Thank you very much. So we need a red circle. Are we there? We need a red circle. Yes. Zoom. Thank you. So red circle finally. Okay. And the rest of the red and green must be gone. Okay. So the rest of the red. Okay. The rest of the red must be gone. There. And the red show up here, the green has to be gone here. Okay, and then of course we need a dot. We need a dot right here. So at the pi. Oh. Right. That's the picture. That's the picture. Okay, so this piece, the black piece is 1 plus sine x for x less than 0. From between 0 to pi, it's a cosine, okay? From 0 to pi. So we have 2 dots. And the sine x does not include, the rule for sine x does not include pi. So we put a circle here and the rest is sine pi. So that's our piecewise function. Domain and range. What is the domain and what's the range? The domain is all real numbers. Okay. Domain is all real numbers. From negative infinity to positive infinity. How about range? Range. How about range? Range, you can see the highest, the lowest, right? Because you have sine, or the highest is attained by 1 plus sine x. So the range probably would be from -1. I mean, not probably, yes, it is for sure, from -1 to +2. Okay, so that's the range. Yeah, then you can do the one that we didn't do earlier by similar way. Since we can do it this way, so how about we just do that? We just do that, right? So this is the picture. This is the picture. Make sure you understand this picture, okay? If you have any questions, please don't hesitate to get to me. And did I make it clean? Yeah, this piece has to be clean. Okay, I'm gonna put a line there, right? To repair, right? To repair, right? So this is the graph for that piecewise function. So now, without further ado, let's go back to the function we left out, right? I think we can use this method to complete that question, okay? So now let's go back to the function we left off at the beginning, and that will be the end of our lesson here, right? So the software doesn't run for us, right? So let's see if it will run for us again. You know what? Maybe we should graph it, use our, and then we try to see if we will run it again, okay? Because I don't want to run the risk. I'll do that later. Sine x, cosine x, right? Less than pi over 4, greater than equals to pi over 4. So what we have is that I'm going to draw this picture. I'm kind of drawing this picture, right? And so we set up the view. It's defined on the entire number line. Okay, it's defined on the entire number line. Okay. And set up the rectangular system. So we're going to draw sine x, cosine x. Okay, sine x, black, cosine x, red. There we go. Obviously, we cannot have all of it, right? We cannot have all of it. For less than pi over 4, so we have to first locate what is pi over 4. At a pi over 4, cosine pi over 4 is what? Cosine pi over 4 is what? Root 2 over 2, right? So so we first identify that point, pi over 4, and then root 2 over 2. So that's going to be a dot. Okay, that is going to be a dot. Sine pi over 4 is going to be a circle. Okay, so sine pi over 4 is going to be a circle. Okay, so pi over 4 and root 2 over 2. We're not going to see that circle because, you know what? Let's not do it for now. Okay, let's not do it for. So this is the point on cosine curve. Cosine is red, but cosine is from pi over 4. So this point is pi over 4. Okay, this is pi over 4. So cosine start from here. Okay, cosine, the red start from here. So all these black need to be removed. Okay, so now I think I'm probably better at this now, right? So these pieces, oops, sorry. I need to use a white. I need to white it out. Okay. So these pieces is going to be gone. Wait. Okay, these pieces need to be gone. What's going on? There. Doesn't white it? Oh, what a dumb software. Or I'm pretty dumb to using these, right? So these black, which is the sine piece, beyond pi over 4, it has to be gone. Huh. You can see it's a learning process, right? So this probably simulate your working on paper. Oh, you know what? I'm going to use the other tool. There, right? There. Use the rectangle. Right here. Okay. And I'm going to use the white, just white it out. Okay. Gone. Oh. There. Right, well, we'll have to do some repair. We'll do some repair work. There. Whew. And the red, which is the cosine, we have to erase it from this side. Right, we have to erase it from here. So the picture we saw, so let's remove the red. Remove the red on this side. Okay. And we're going to do some repairs. Okay, so this will probably simulate what you do on paper. Some people like to do this. I don't. Okay. There. All right. Oh my God. So here is going to be a dot. Why is it going to be a dot? Because at the point of intersection, the sine and the cosine overlap at this place, and they have the same function value. So that's why here it's just going to be a dot. We don't have a chance to make a circle. Well, you know, I'll have to come back to clean it up. Okay, so this is going to be a dot. The dot is going to be here. And add pi over 4, comma, root 2 over 2. Okay, so let me erase it really clean. Okay, I don't want you to have the false impression. Okay, it needs to be clean. Okay, we'll come back to repair. So this is how the curve look like. This is how the curve look like. I'm going to do some repair. Okay, so the line will be, whoops. The line would be nice and straight. Okay, so you're going to have your line and these lines and these lines. Okay, and that point is our midpoint. If you want to mark it, that's pi over 4 root 2 over 2. What do we see here? What do we see here is that this piece is sine and the red piece is a cosine. It must be a function. It must be a function. Okay, and this function is composed of two pieces. Okay, and at this point, there's a sharp turn. Okay, it's totally likely your calculus teacher can make some use of it, right? But anyway, so this is the function. So we have graphed all the functions we intended to graph in our plan. So last but not least, I'm going to run the program one more time. Okay, I'm going to run the program one more time. If it doesn't work, it doesn't work, right? So I'm going to put this on the very, very top. and clean up, okay? If it runs, it will see it. If it doesn't, then we're gonna close this lecture, okay? And it doesn't look very good. It doesn't look very good. Okay, never mind. Okay, so I will see you guys next time, but we got the picture, right? We got the picture on record. So thank you for watching. Until next time.